I am R. Prabha, Assistant Professor in the Department of ECE, SNS College of Technology. In this video, we will discuss the topic double stub matching for the course Transmission Lines and Antennas. So, there are some disadvantages of single stub matching we have discussed in the previous video. The single stub matching is applicable for only one frequency. For final adjustment of the stub has to be moved along the line, and it is possible for open wire line and it is difficult for coaxial line. To overcome these drawbacks of single stub matching technique, we go for another method called double stub matching, which is employed in a transmission line to achieve impedance matching. So in double stub matching, there are two short circuited stubs of length L1 and L2 are used. Stub 1 is of length L1 located at distance D1 from the load, and similarly stub 2 of length L2 is located at distance D2 from the stub 1. And the input impedance for a lossless line at any point distance S away from the load, we have know the formula of input impedance Zs equal to Z0 Zr plus J Z0 tan beta S by Z0 plus J Zr tan beta S. Now we are changing all the impedances value in terms of admittances because we are making parallel connection of the stub. So we have to deal admittance is very easy. So Zs is replaced by 1 by Ys, Z0 is replaced by 1 by Y0, Zr is 1 by Zr. So by replacing we get 1 by Ys at the left side is equal to 1 by Y0 and multiplied by 1 by Yr plus J 1 by Y0 tan beta S by 1 by Y0 plus J 1 by Yr tan beta S. So Y0 by Ys equal to 1 plus Yr by Y0 tan beta S by Yr by Y0 plus J tan beta S. So this is obtained by multiplying Yr in both numerator and denominator of the right hand side. So this Ys by now we are inverting this equation. So Ys by Y0 we obtain at the left side, which is the normalized admittance. At the right side we have Yr by Y0 plus J tan beta S by 1 plus Yr by Y0 tan beta S. So this Ys by Y0 is substituted as small ys, which is the normalized input admittance, and Yr by Y0 is substituted as small yr in the equation 4, which is the normalized load admittance. So now small ys is small yr plus j tan beta s by 1 plus j yr tan beta s. So in order to rationalize, we get multiplying and divided by complex conjugate of the denominator, we get the final value of admittance Ys equal to Yr into 1 plus tan squared beta s by 1 plus Yr squared tan squared beta s plus J 1 minus Yr squared tan beta s by 1 plus Yr squared tan squared beta s. So this is the separation of real and imaginary parts of the normalized admittance value Ys. So this is kept as equation number 6. So now stub 1 is located at point A dash at a distance S equal to D1 from the load. So substituting S equal to D1 in the equation number 6, we get equation number 7, and this Ys is Gi plus Jbi. Gi is the conductance and Bi is the susceptance. Now stub 1 is having the susceptance plus or minus Jb1 is added at this point. So the new admittance will be Ys dash equal to Gi plus Jbi dash. Here the new susceptance Bi dash is Bi plus or minus B1. So at B comma B dash, the normalized load admittance is Yb dash equal to Ys by G0 1 plus or minus B2. So here stub 2 is adjusted such that its susceptance is minus or plus Jb2. So this plus or minus Jb2 minus or plus Jb2 is get cancelled. We get Ys dash equal to Ys by G0 or Ys equal to G0 which gives Zs equal to R0. So this is the required condition for impedance matching is achieved by using the two stubs in this way. So the spacing between this stub should not be more than or equal to lambda by 2, which is the resonant length. So we can take the lengths maybe lambda by 16, lambda by 8, 3 lambda by 16 and 3 lambda by 8. But the most common separations are lambda by 4 and 3 lambda by 8. So problem is given, Zr by Z0 is given directly 0.8 plus j 0.2. So the distance between the stub is given 3 lambda by 8. So we have to design a double stub tuner. So here YR by G0 is obtained by inversing Zr by Z0. It is 0.4 minus j 0.6. It is marked on the chart. In the next step, we have to draw the unit circle, and step 3 we have to draw a circle which lies between point 1 on the horizontal axis and the reactance value of 3 lambda by 8, that is 0.375 lambda. And in step 4, move the line from the normalized admittance without changing the real value. It cuts the 3 lambda by 8 circle at point 0.4 minus j 0.2. This is the point where stub 1 is connected. So step 5, the difference between the susceptance is calculated, and according to our problem it is j 0.4. And next we have to find the susceptance value at a point where unity circle cuts another circle has radius of the center point of stub 1 connection. And in the step 7, the susceptance value at that point is plus or minus j1. The opposite susceptance minus j1 is obtained. So this is the point where stub 2 is connected. So this is shown solved in the problem in the diagram. And now the assessment mention the disadvantages of single stub matching, and what is the expression of input impedance of a dissipation line. We can get easily the admittance from the impedance from the Smith chart by taking the diametrically opposite point. Thank you.